Today I'll show you how to make things pop up in the third dimension. I'll call this process extrusion and we'll extrude everything. The buildings, the cars, the road borders, the trees. Okay, maybe not the trees. We'll deal with those later. Now I want to show you something really cool. How to move the camera behind the car so we can see it as well. And I'm also going to show you a trick that racing games use to give a real feeling of speed. I'll expose you to some really cool things. You'll see. Get it? Expose? Because cameras have an exposure. No, 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 no.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
Let's give these buildings here now some height. We are going to do that by going in camera.js in the render method. After we have our polys here, we are going to extrude them vertically in the z direction. So we can do that with a new method. Let's call this one extrude, like this. And I'm just going to put this on a new line and then here close. And extrude is going to be up here, given some polys and a given height, let's say 10 by default. Similar to filter, let's prepare the extruded polys array here and loop through all of the polys. And these are the building bases now. So let's get the ceiling as well. The ceiling is going to be a new polygon. And let's take the points from the poly, from the base, and remap them so that each point becomes a new point, also at x and y, but with minus height for the z. Then extruded polys is going to get both of them. So let's push the base and the ceiling like that. And finally, return these extruded polys like so. Now, the points that we have been working with so far have just x and y. We don't have the z yet. And this is going to change now, but only minimally. I mean, the game stays a 2D thing, mostly. It's just this projection that we do now that is going to be special and in 3D. So we won't be modifying everything to work in 3D. The car won't be able to jump around. As little as possible change to make it work. Let's set z here by default 0. And then here store this value as an attribute. So now only these ceiling points in the whole application are going to have a different z than 0. And we need to change the code that does the projection slightly. So here we need to say p.z minus this.z, and this needs to be in parentheses. It's very important. So the difference on z here is what we are going to use. Now save, refresh, and each building looks kind of like a sandwich. Let's make the sides of the building. So back down to our extrude method. After we have the ceiling, we can easily generate the sides. Let's have an array for them. And I'm going to loop through all the points of the given poly, one by one, like this. And generate sides for each consecutive pair, like so. Each side will be a new polygon. And let's add here the points one by one. So the first one is poly points of I. And the next one is poly points of I plus 1. But this is going to give an error when we get to the end here. And we do want to loop back to 0. So the last point in poly points should connect back to 0. And the easiest way to do this is to take the modulo according to this poly points length there. And now we do the same thing for the ceiling, but in reverse. So we start with ceiling points I plus 1 modulo ceiling points dot length, and then ceiling points of I. And these sides are what we have to pass to extruded polys as well. Maybe we don't need the base anymore. I mean, the sides are going to cover it. And here I just spread the sides like this. Let's save, refresh, and now these look like some kind of boxes. Let's have them taller. So in render here, when we extrude, we could pass a different value for the height, maybe 200. Save and refresh. And now this looks like some really, really tall buildings there. Wow. This error that happens here in this very specific point took me about a day to figure out. Let's see if you can figure it out. I'm just going to show you how to fix it. Let's open the polygon here. And going to the contains point, I'm gonna do this. Let me know in the comments if you figure out what was wrong in that location. Save and refresh. And now if we go there, there's no problem anymore. Everything looks just as expected. Let's see if we can see the cars as well. Like, maybe it's interesting to see how the cars look like from this car's perspective. Can we see this one coming ahead? Back in camera.js, these are really the building polys now. So let's rename it to building polys and copy this for the car polys. Now these won't be so tall. Maybe we put here just 10 and let's rename this to car polys. And we generate these from the world cars like this, where each car C is going to become, and let's write this on a new line here because it's longer, a new polygon from C polygon. And this might be a bit confusing. The polygons of the cars that we had in phase 1 weren't really polygons, they were just collections of points. So we are going to remap these to actual points because they weren't even points. They were just XY pairs there, not point objects. And the polygon works with point objects. So now these car polys are proper and we can combine them into the polys. It's equal to both of those. Like this. Now let's save and refresh and look at that crazy things happening here. So I'm going now alongside these other cars and wow, this is so confusing somehow. We need the road borders. I think that will make it more clear what is going on. But so many cars are really confusing here. And it's also slowing down the interface quite a lot. Like if I'm looking at all these cars that are piled up there, I can sense lag lag in the system. Maybe we can do something about that, but let's see. Anyway, you can try other things as well here, like maybe the trees. Let's try copying this one. And this is tree polys, world trees. And then here, let's add tree polys as well. Save and refresh. And they don't really look like trees. They have this strange shape. And it's really slow. Like there are a lot of polys here overlapping, and it's crazy. We can make them look like trees. I might show you this in the final lesson when we do the fine tuning. But for now, let's not have the trees there. What is really important to have is the road polys so that we see the side of the road. Road polys. Here we use the world corridor borders like this. And here, these are segments. So S is going to become a new polygon with s.p1 and s.p2. And this may look a little strange. How can a polygon have just 2 points? But it works, and it's going to be extruded up. So each one of these segments will become a standing rectangle. A shorter one. We don't need this to be 200, so maybe 10 is going to be enough. And let's pass these road polys here instead of tree polys. Now save, refresh, and this is what we get. The corridor now looks really nice. And what happens to the left side there? The problem is, if I'm gonna look at it straight on like this segment here is long and straight. Not a single point of this one is inside of the triangle. So our logic from previously doesn't work. Let's fix it. It's in the filter method here where we keep the polys. We can't do this anymore. Let's just remove it entirely. And here, this else if this poly, so the triangle of the camera, contains poly, now this is going to work. And the reason why this works is because the intersects poly is going to trigger when that long segment is going to be in that position here. It's not going to be skipped like before. Let's refresh and go to the same location. And you can see now this is not a problem anymore. Okay, let's also refactor here a little bit because the render method is becoming quite long, and all this thing is doing at the top is getting some polys to render. So we can have get polys from the world, and this is going to be just, let's copy everything here inside, and we can return this array. And down here, we don't need everything there. We just say that polys is equal to this dot get polys from the world. And now this is much clearer. We get the polys, we project them, we draw them. And we don't need this drawing anymore. It's just wasted processing power. Now save and refresh, and everything still works. It's even a little faster than before. but not by much. Now, this view of the car is okay. We could use this even as an input for the neural network, like a sensor, a complex sensor, like coming from the camera. But when I drive and when I play these kind of games, I don't do good in this view. I like to see the car from behind. Let me show you how to make the camera go behind the car and follow the car. So at the top here, when we define it, let's also give it a distance behind, let's say 200. And let's set this here as an attribute of the camera. And we're going to have to use it here to modify the x and y. So according to the unit circle, we multiply this distance behind by the sine of the angle in this case, and here by the cosine of the angle. This is again that weird twisted unit circle from phase 1, but this is how you get it to work. Now let's save, refresh, and there on the top you can see that the triangle is behind, and now we can see our car there nicely, but I think we can get a better view from a little bit higher and a little bit more up close. So let's change this z here to minus 40 maybe, and this distance behind, let's try 150. Save and refresh. Yeah, this is much nicer now. But in racing games, those that I like to play at least, the camera isn't so stiff. It's moving. Like if the car is speeding up quickly, the camera is somehow left behind, and that makes for a really nice sensation of speed. And we can do that relatively easy, actually. I'm gonna show you. This is a function that just moves behind the car, and that's it. But we are gonna make a more complex version that does a little bit more. Let's rename the previous version to move simple and rename it here in the constructor as well. That's what we do in the initialization. And in the complex move, we are going to go up here and set a parameter for how smooth we want this camera movement to be. Like t is equal to 0.1. And here we are going to wrap each of these in a lerp between this x and the new value that we want to calculate according to this t. And we do the same thing for y, like so. So the camera is trying to go to the new location, but not immediately. And we do the same thing for the angle as well. The angle is also going to try to catch up from this angle to angle, and also according to t. Save and refresh. And look at that. The car, when I'm slowing down now, is getting closer to the camera. And when I speed up and I'm going really quickly, the camera is somehow left behind. I really can't explain how much of a difference this makes. I did find this video though. It talks about many things, not just this effect. So check it out if you're into making games. I think it's really useful to know that stuff. Okay, I think these cars there are just really confusing. When racing, it's going to be so that if those cars don't know that I exist, I don't want to know that they exist, because they are really distracting. I can't focus on the road. I try avoiding them maybe, or do something and considering them. So let's remove them. It's also going to speed up this significantly. When we get the polys there, we just don't add them here. Save and refresh. Oh, now we don't know where we are because the cars includes our car. But it's actually part of the world best car. The best car in the world is our car. It's still like that because we show it separately. So here we can say best car. Actually, no, we just take world best car and pass it here to new polygon. So we are going to take the world best car polygon, map it to a new point. But this needs to be inside of an array here because filter expects an array of polygons there. So let's just do this and add these car polys. It's just one now, but yeah, here so that it appears again. Save and refresh. And now that bottom view is really clean. I can work with that. Okay, let's re-enable the damage from the sides of the road. So in car.js, we return the normal stuff here. Let's also go back to race.js at the top and set this started to false so that it starts with the counter. And now I will unmute the website. So let's test one more time and with the sound. And it broke. There is one more problem here. The best car polygon doesn't exist before we call car update. And now inside of race.js here at the bottom in animate, update is only called after starting, but it still tries to display the things. So in car.js here, there is no sign of that polygon until this update is called. I think that we can call update once with these empty values at the end of the constructor. So after constructing this, let's try this update and empty array, save, refresh, and things seem to work again. Let's close this and refresh and play with the sound. Okay, I smashed into the wall there, but nice. And of course, if you want to have the full screen, the 3D mode, you can do that quite easily. Maybe set this car canvas to 0 and this one to the full screen. In that case, you might even want to comment out the world drawing from here because we don't need to draw the world from the top view anymore. It's just wasted resources. And now save, refresh. Wow. Okay, this looks really nice.